You know how sometimes you really need to understand something complex, but you just don't have the time to wade through tons of research?
Yeah.
This deep dive is perfect for you then. We're going to be exploring a paper about a new AI system that solves math problems better than ever before,
Wow.
and it does it in a way that's surprisingly similar to how WE think.
Yeah, this is a fascinating paper. The
Yep.
title is a mouthful, rStar Math. Small LLMs can master math reasoning with self-evolved deep thinking.
Okay.
But it highlights a really novel approach using small language models to achieve state-of-the-art math reasoning.
Oh, sorry. Did you say small language models?
Yeah.
Beating out the giants.
Yes, that's what's so intriguing about this.
That's fascinating already. And they use something called deep thinking.
Yeah, it's not about AI like pondering the meaning of life or anything.
Right.
It's more about a more deliberate and strategic approach to problem solving.
Right.
Star Math enables these smaller language models, or SLMs,
Okay.
to engage in what we call system two thinking. Yeah, a slower, more analytical process that's similar to how humans tackle complex problems when our, gut instincts aren't enough.
So it's less about just rapid fire calculations and more about carefully considering all the different approaches, like
Exactly.
we might do at a tricky logic puzzle or something like that.
Yeah, and it's all thanks to a pretty clever combination of techniques,
Okay.
starting with something called Monte Carlo tree search, or MCTS.
CTS.
Yeah, imagine the SLM exploring a multitude of potential solution paths,
Okay.
almost like branching out on a decision tree.
So it's a bit like the SLM is saying, okay, let's try this approach. Not quite. What about this angle? Getting closer.
Yeah, a great way to visualize it. But
Boy.
what really sets Star Math apart are three key innovations
Right.
that make this deep thinking process really effective.
All right, now you've really got my attention.
Okay.
What's the first one? What makes Star Math so special?
The first one is what the researchers call code-augmented data synthesis.
Code augmented COT.
Yeah, code stands for chain of thought,
Okay.
which essentially refers to the step-by-step reasoning process the SLM uses
Right.
to arrive at a solution.
Makes sense.
Now, here's the ingenious part.
Okay.
Star Math not only generates these reasoning steps, but verifies them using actual Python code execution.
Oh, wow.
So
So it's not just thinking about the steps, it's actually doing them,
yes,
making sure each one is logically sound and mathematically valid.
exactly.
It's like having a built-in proofreader for every calculation.
Exactly. This significantly minimizes errors and ensures a much higher degree of accuracy than we typically see.
Wow, that's impressive. But even with the most meticulous calculations, we all know how easy it is to get stuck or head down the wrong path.
Right.
How does our star math keep these SLMs on track and prevent them from getting lost in a sea of equations?
That brings us to the second innovation, the process preference model, or PPM.
PPM.
Yeah, think of it as an AI mentor guiding the SLM toward the most promising solution paths. The PPM learns to evaluate the quality of each reasoning step, offering hints and feedback along the way, much like an experienced tutor would.
So it's not just about brute force calculation, it's about strategy and learning to recognize which approaches are more likely to lead to the correct answer.
Precisely. The PPM essentially helps the SLM develop a sense of mathematical intuition, guiding it towards elegant and efficient solutions.
This is fascinating. We've got an AI system that thinks deeply, checks its work, and even gets expert guidance.
Yeah.
What's the third innovation that completes this picture of a star math?
This is where things get really interesting.
Okay.
The third innovation is what they call self-evolution.
Self-evolution.
Remember how we talked about these SLMs being small compared to the massive language models we often hear about?
Right.
Well, the Star Math starts with these relatively simple SLMs,
Okay.
and through a clever process uses them to generate increasingly complex and accurate training data.
So they're not just solving problems, they're using those solutions to learn and improve, becoming more sophisticated with each iteration.
That's a great way to put it.
It's almost like they're evolving in real time.
It's this self-evolutionary capability that allows Star Math to achieve such remarkable results, even with smaller, more efficient models.
Okay, you've piqued my curiosity.
All right.
We've talked about how star math works, but what about the results? Can these self-evolved SLMs actually hold their own against human mathematicians?
The answer is a resounding yes.
Oh.
A Star Math achieves impressive performance on a range of challenging math benchmarks,
Like what?
including problems from the USA Math Olympiad, or AIM,
The AIM.
a competition known for its difficulty.
Now that's a real test. The AIM is designed to challenge even the brightest high school math students.
Right.
How does star math measure up against that level of competition?
So using a 7 billion parameter SLM, which is considered small in the world of large language models,
Right.
Star Math is able to solve an average of 8 out of 15 AMEM problems.
Wow. So that puts it in like the top 20% of high school students taking the exam? That's incredible. It's not just crunching numbers, it's demonstrating a level of problem solving and logical reasoning that's on par with some of the brightest young minds out there.
And remember, this is a system that essentially started with a relatively simple SLM and through self-evolution reached this level of performance.
It's a testament to the power of this approach and what it might mean for the future of AI.
Yeah.
Okay, I need a moment to process all of this AI that thinks deeply, checks its work, gets expert guidance, and even evolves to solve complex math problems.
It's pretty remarkable.
It's like something straight out of science fiction, but it's happening right now. Definitely ready to dive deeper into the implications of all of this.
Okay.
What else can you tell us about SAR-Math's capabilities and what these findings might mean for the world?
What's truly fascinating is that rStar Math's success with these smaller models, it might point to a larger shift in AI research.
Oh, really?
It challenges that assumption that bigger is always better.
Right.
And highlights the potential of, focusing on efficiency and smart design
Okay.
over sheer scale.
That's a really interesting point. We often hear about these massive language models with billions, even trillions of parameters.
Exactly.
It makes you wonder if there's a point of diminishing returns
Yeah.
or even like unintended consequences when it comes to building ever larger AI systems.
Absolutely. While large models have certainly achieved impressive feats,
Right.
they come with their own set of challenges. They're incredibly resource-intensive to train, requiring vast amounts of data and computational power, which raises environmental concerns.
So it's not just about performance, it's about sustainability too.
Exactly.
SAR-Math's success with smaller models suggests that we might be able to achieve similar or even better results with a more mindful and efficient approach.
Precisely. And this focus on efficiency could democratize access to powerful AI tools.
Oh, wow.
Imagine a world where researchers and developers, even those with limited resources, can leverage these techniques to create innovative solutions without relying on massive computing infrastructure.
That would be a game changer. It could unlock a wave of creativity and innovation across various fields.
Right.
But let's talk about the potential applications of star math.
Okay.
We've touched on its math prowess.
Yeah.
But where else could this technology make a real-world impact?
Oh, the possibilities are vast.
Okay.
One area that immediately comes to mind is education.
Okay.
Imagine every student having access to a personalized AI math tutor
Okay.
that can guide them through complex concepts, adapt to their learning style, and provide real-time feedback.
That would be incredible,
Ah.
especially for students who might not have access to the best teachers or learning resources.
Right.
It could truly level the playing field when it comes to STEM education.
Exactly. But it's not just about helping students solve equations.
Right.
It's about fostering a deeper understanding of mathematical principles. Encouraging them to think critically and creatively about problem solving.
And that goes beyond just math skills. It equips them with valuable tools for navigating a world that's increasingly reliant on data and logical reasoning.
Yeah.
What other fields could benefit from our star math's capabilities?
Well, remember how star math uses code execution to verify its reasoning?
Yeah.
This suggests that its core principles could be applied to other domains involving logic and structured problem solving,
Okay.
such as computer programming.
So we could potentially have AI systems that not only write code, but also rigorously check their own work,
Exactly.
identifying errors and bugs before they become major issues.
Right.
That would be a huge leap forward in software development.
Imagine the implications.
Yeah.
More reliable software, faster development cycles,
Wow.
and perhaps even the ability to create systems that are far more complex than anything we can build today.
It's almost like having an army of incredibly meticulous programmers working around the clock.
Huh, yeah.
Now, I have to ask about those AIM geometry problems that SAR app didn't quite crack.
Right.
Does this highlight any limitations of the system?
Yeah.
Or are those challenges on the horizon for future development?
That's a great question. And it does point to an area where SAR math, in its current form, has room to grow.
Okay.
It excels in problems that can be tackled through symbolic reasoning and code execution. Geometry problems, particularly those involving spatial visualization,
Right.
require a different kind of thinking.
So it's not just about logic and equations, it's about understanding shapes, angles, and how they relate to each other in a visual space.
Exactly. But the researchers are already looking into ways to incorporate visual reasoning capabilities into star math.
Oh, wow.
They envision a system that can not only solve abstract mathematical problems,
Right.
but also analyze diagrams, understand spatial relationships, and even generate its own geometric proofs.
That would be an incredible leap forward. It would expand star math's capabilities significantly and open up a whole new realm of possibilities.
It's a testament to the researchers' ambition and vision. They see our star math as more than just a specialized math-solving AI.
Okay.
They believe it has the potential to become a truly general-purpose problem-solving system applicable to a wide range of domains.
That's really exciting. But before we get too carried away with future possibilities,
Yeah.
I'd love to explore one of the findings that struck me as particularly fascinating:
Okay.
the emergence of intrinsic self-reflection in our star math.
Yes. That's one of the most intriguing and unexpected aspects of this research.
You mentioned earlier that our star math engages in a more deliberate, human-like thinking process,
Right.
but self-reflection takes that a step further.
Yeah,
It suggests a level of metacognition and awareness of one's own thought processes.
exactly. The researchers observed instances where star math seemed to recognize its own errors,
Okay.
backtrack, and adjust its approach.
Wow.
Much like a human student might realize they've made a mistake and try a different strategy.
So it's not just blindly following algorithms.
Right.
It's demonstrating a level of flexibility and adaptability that's quite remarkable.
Yeah, and what's particularly fascinating is that this wasn't explicitly programmed into the system.
Really?
It seems to have emerged organically as a result of the deep thinking process enabled by our star math.
That's what makes this finding so significant.
Yeah.
It suggests that by creating systems that encourage deep reasoning and exploration,
Right.
we might inadvertently unlock capabilities that we didn't even anticipate.
Exactly.
It raises questions about the very nature of intelligence and learning, both in machines and in ourselves.
It really does.
It makes you wonder what other hidden capabilities might emerge as we continue to develop and refine AI systems like our star math.
Yeah.
Are we on the cusp of a new era of AI, one that's characterized not just by computational power, but by a deeper understanding of thought processes and problem-solving strategies?
It's certainly a possibility, and this brings us to another crucial aspect of this research,
Okay.
one that has far-reaching implications for the future.
What's that?
The potential of star math to change how we humans learn and approach problem solving.
This is a topic I'm particularly interested in.
Yeah.
We often think of intelligence as the ability to recall facts quickly
Right.
or to solve problems through sheer processing power.
Mm-hmm.
But star math suggests that there's another dimension to intelligence,
Mm-hmm.
one that emphasizes deep thinking exploration and learning from mistakes.
It challenges our traditional notions of what it means to be intelligent,
Yeah.
and it has profound implications for how we educate future generations.
Instead of focusing on rote memorization or drilling students with formulas,
Right?
perhaps we should be encouraging them to embrace a more exploratory approach, to experiment with different strategies, and to view mistakes as valuable learning opportunities.
Exactly. It's about cultivating a growth mindset,
Right.
where students are encouraged to embrace challenges and to see learning as a continuous journey of discovery and improvement.
And this goes beyond just academic settings. It applies to all aspects of life.
Right.
In a world that's becoming increasingly complex and unpredictable, the ability to think deeply, to adapt to new challenges, and to learn from our experiences is more valuable than ever.
It's a powerful message, and one that resonates with another crucial aspect of star math,
Oh,
its potential impact on the future of work.
this is a topic that often generates a lot of anxiety.
Understandably.
People worry about AI taking over jobs, automating tasks that were once considered uniquely human.
Right.
What does our star math tell us about this evolving relationship between humans and AI in the workplace? It seems like whenever we talk about AI, the conversation always goes to jobs.
Yeah.
Some people are excited about AI and think it will free us up from all the boring stuff,
Mm-hmm.
but then others are worried about AI taking over their jobs.
Right. It's a tough question.
Yeah, so where does Sardamath fit into all of this?
Well, it doesn't give us like a simple answer,
Okay.
but I do think it gives us a good way to think about how humans and AI are going to work together. Like
Okay.
instead of thinking that AI is going to replace us,
Right.
We should think about it like a tool that can help us be even better.
So it's not AI versus humans. It's
Right.
more like AI and humans working together,
Exactly.
both using their own strengths to reach a shared goal.
Exactly. Like, think about doctors.
Okay.
They could use something like rStar math to analyze tons of medical data. They could maybe diagnose things better or come up with really specific treatments for each patient.
So it's not like the AI is replacing the doctor.
No, not at all.
It's more like it gives them more information so they can make better decisions.
Exactly. And then the doctor can focus more on the patient,
Yeah.
talking with them and being there for them.
Right. It frees them up to focus on being human.
Exactly. And this could work in other fields too.
Okay.
Like, what if architects used AI to design buildings that were better for the environment?
Yeah. Or musicians working with AI to write totally new kinds of music.
Exactly. Think of all the new things we could create if AI could boost our own creativity.
That's really exciting. But are there any concerns about this, like ethical questions we need to think about?
Yeah. You bring up a really important point.
Yeah.
AI is powerful, so we need to be responsible with it.
Okay.
We need to make sure that it's fair and doesn't hurt anyone.
So it's not just about making AI smarter. It's about making AI that's good for everyone.
Exactly.
And how can we make sure that happens?
I think we need to talk about it a lot.
Yeah.
We need to learn about what AI can do, but also what it can't do.
Right. We need to understand it.
Yeah, and we need to talk about the ethical stuff.
Okay.
And we need everyone's opinions on this, not just the tech people.
So everyone needs to be involved in figuring out how we want AI to be used.
Absolutely.
Well, this has been an awesome deep dive. We started by talking about one paper, and now we're talking about the future of AI and what it means to be human.
I know. It's pretty mind-blowing.
So to our listeners out there, we want to know what you think.
Yeah.
What surprised you the most about star math?
Mm-hmm.
Are you excited or worried about AI? Head to our website or social media and tell us what you think.
We want to keep talking about this with all of you.
And until next time, stay curious, keep exploring, and remember that the future of AI is something that we all create together.